Great. What I'd like to do is that I'd like to start for today. So welcome everybody to our next installment of our United Nations Development Program, virtual STEM and robotics program. And today we're going to cover Internet of Things, and we're also going to have a look at our robotics ideas. So without anything further, let's actually just go through our overall format for today. So yeah, we started at 11. I'd like to know how it went this week. We all had an experiment to do, which was, is there a relationship between natural light intensity and temperature? Let's have a discussion about Internet of Things, how all of that works, so that we can then understand exactly how our dashboards work and how to put together our dashboards. I have an example of a dashboard that I built, and so I took some photograph of my kits, and I'm going to share with you the dashboard. Then we'll have our break between 12, between noon and 1. What we can do is we can have some breakaway rooms. We can maybe do a little bit of troubleshooting. We can do some tips and tricks with how to build dashboards during that break. And then after the break, I'd like us to go through the experiments that we're going to have for completing over actually the next 2 weeks. So all of the assignments and everything is due on the 30th, because I do know that a lot of you are writing exams and tests for the end of term over this next week. So what we'd like to do is give you quite a bit of time to be able to do these experiments. And so there's 2 experiments from now on. And the first one is, does the fridge light go off when I close the door of the fridge? And then the second one is, does it still get colder after daybreak? Now, that second experiment, does it still get colder after daybreak? You're going to need to connect your kit and collect data over a number of days. So that is why it's really important that we make sure that your kits are up and running, that you've got a reliable power source, and that you have your dashboard running during that time. And then we'll close off with some more robotics ideas. So what I'd like to do now is actually stop sharing, and let's see, does anybody want to come in and discuss how that experiment went this week? Is there a relationship between natural light and temperature?
Hi, Judy.
Hi.
I see Riza's in the room, and I actually got a submission from Riza. So if Riza Kluter wants to unmute himself and discuss his findings, that would be awesome.
Hi, morning, everyone.
Morning, hi.
Yes, so I submitted my table and everything to Brittany. And what I found out was I had my stuff right here, that my first analysis from the front yard was the temperature was 26.50 degrees Celsius, and the lux level was 102,073. And for the backyard, it was 28,61 degrees Celsius, but the lux level was 99,800. And for behind the house, the temperature was 27,13 degrees Celsius, and the lux was 11,692 because of the trees behind the house.
Okay. Okay, so did you find that there was a difference, that also the environment around where you were collecting the data, did you find that there was a difference there? You mentioned that the influence of trees.
Yes, because of the trees, there's less light from the sun. So obviously the lux level will be lower.
Yes. Yes, absolutely. So yes, you're in the shade of the trees. I was wondering, were you able to, did you also have a look at your UV index to see if there was a difference there?
Sadly, I had like a few problems with the UV index because sometimes it would just stay on 0 or just stay on like 1 or so.
Okay. Okay. No, that's absolutely fine. And the reason why I ask that is because trees and plants are very good protection from UV, from ultraviolet light. And so what one has is one has a lot more protection. If you're standing in the shade of a tree, you have a lot more protection from ultraviolet light than you would have if you were, let's say, under an umbrella. So certainly that does come into effect. Also, let's see if there was anybody else who collected data, and we're looking specifically for an area where there's a lot of vegetation, maybe where there's quite a bit of grass or plants. Does anybody have a case like that where they collected their data in where there was a lot of vegetation? If you would like to, you can make some comments in the chat. Liam, do you have some input here?
Sorry, I accidentally unmuted myself.
Okay. Great.
Ma'am?
Yes, hi.
Hi, ma'am. While I was taking the data on the vegetation, the temperature was lower. I noticed that the temperature was lower where there was a lot of grass, but the lax reading was still the same, though. It's just that the temperature was low.
Absolutely. And please, you must call me Judy. So yeah, definitely that's a very strong observation. And there is a reason for that. And in one of your previous quizzes, what we did is we had a look at photosynthesis. So photosynthesis is the process where plants convert light into food and energy. And so the thing is that what happens is that process, what happens is that the plants use the photons, the energy from the photons, and what that does is that engages with the chlorophyll. Sorry, Brittany, if you wouldn't mind just managing some background noise there. That what happens is that the chlorophyll is the chemical or the enzyme in the leaves that not only produces the green color of the leaves, but what it does is that the light is absorbed by the chlorophyll, and the chlorophyll converts that to energy. During that process, carbon dioxide from the atmosphere is also absorbed by the leaves, and what happens is that the plants in a way exhale the oxygen. So the carbon dioxide is absorbed, the carbon becomes part of the plant cell, and then the oxygen is released. That chemical process, in order for that chemical process to take place, there's an absorption of heat from the environment, because it's known as an endothermic reaction. So an endothermic chemical reaction is when it absorbs heat, it needs more energy, so it absorbs heat from the environment in order for the chemical process to occur. An exothermic reaction is when it gives off heat. So for example, an example of an exothermic reaction is the combustion reaction, where what we do is we have a fuel and we add oxygen, and then what that does is that produces carbon dioxide, water, and heat. So what the plants are doing is the plants are doing a reverse of that reaction. The plants are taking the carbon dioxide and then converting that to carbon and oxygen. So it's an endothermic reaction, because we basically we're reversing that combustion reaction. So the thing is, what's happening is, Grace, you're very correct. What you have is you have this environment with a lot of plants, and a lot of light from the sun, because you had a very high lux level. So the plants are really, they are doing their job. The chlorophyll's doing its job. And so you're finding that there's a lot of carbon dioxide within that environment that's being absorbed because the light's hitting the plants, it's getting that reaction going. And in the process, it's absorbing a lot of heat from the surrounding air. So therefore the temperature drops off. So that is definitely a very, very good observation. And this is going to come to the fore when you do the experiment of, does it still get colder after the sun comes up, after daybreak? It's this reaction as well that has a lot to do with it. If you've got a lot of vegetation around, you're going to see, you'll see a different result if you've got a lot of vegetation as opposed to very little vegetation. So certainly that was the case. Does anybody want to add in terms of how do you feel that just under normal circumstances, if you have more light, that you would have a higher temperature? Does anybody else want to give their input on what their findings were? Brittany, yes, please.
It's not about the question that you just asked. It's about what you mentioned just before that, about the next experiment, about does it get colder around daybreak, where you mentioned that you'll get a different result where there's a lot of vegetation versus not. Because there is quite some time before the 30th of September, I think it would be really interesting for the students who can perform that experiment twice to do so in two different locations. So if they are able to do it in a location where they have a lot of vegetation versus not, or even if they pair up. So if in the chat they want to connect and see, or if they want to email me and ask for a partner, that would be awesome, so that they can see those different results. I think that would be cool.
I completely agree with you, because the thing is that sometimes what can happen is that, especially if there's been a dramatic change of weather over those days, then the results may be inconclusive. So yes, you definitely want to be able to collect data a number of times, maybe have a number of different data sets. So I also, at this point, I want to actually send a shout out to both Thea as well as to Shivan, because last week what you noticed, and you actually made a comment about how you were finding that your temperature wasn't changing, and also your pressure, your atmospheric pressure was remaining the same when you were doing your experiments. And thank you very much for that, because what we did is that earlier this week, we realized that because the two of you, and Amina as well, I think you may have found it as well, is that you have an add-on to your XK01 starter kits for the Space STEM program that we conducted earlier this year. And so what you have is you have a different weather sensor. You have the SW01 and everybody else has the SW02. So what we did is we actually checked that out, and we found that there was a little glitch in the code. So thank you very much. What we've done is we've been able to update the code. I've been testing that code for the last 2 days. So what I would recommend for the three of you, that's Thea, Amina, and Shivan, if you wouldn't mind reflashing your UNDP STEM, what we've done is we've done an update to that software. So now it works. It works perfectly for your as well. Lunga said, okay, Milena, I can see you have your hand up.
Hi, hey everyone. I just wanted to start in connection with this experiment about how the temperature varies in different surfaces. If any of you have a swimming pool in your house, what is going to happen, and it's nice to check out. If you keep your temperature and light sensor over the garden, for example, over the grass for a certain period of time, and then you go and you do exactly that period of time, but over the swimming pool. And you're actually going to notice that despite the fact that both the grass and the water receive the same amount of light, the temperatures are going to vary. And it's going to be very interesting to explain why they vary, because the same is the reason that temperatures vary over the ocean and the shore next to the ocean. And that's what creates lots of climate as well.
Definitely, Milena. Yes, thank you very much for that. It makes a huge difference because the what's known as the heat capacity of water is a lot higher than air. So heat capacity is how much energy can a substance absorb for every 1 degree increase in temperature. So you need to apply a lot more energy to water, a body of water, let's say 1 cubic meter of water, to increase it by 1 degree than you would, let's say, for air to increase it by 1 degree centigrade. So what you find is that the water body will definitely absorb a lot of that energy. So if you live very close to the sea, or you live very close to a lake or a dam or a river, what you'll find is that your temperature fluctuations will be a lot less between hot days and cold days, because of the role that huge water body plays. And so, it also explains why, coastal areas are very affected by whether you have a warm current or a cold current. And so that is why the climate is very different in KwaZulu-Natal, especially along the coast, compared to the west coast, which is on the Atlantic with the cold current. So absolutely, Milena, thank you very much. Thank you very much for that. And what I'd like to do now is let's actually go back to where we were with our presentation. So what I'd like to do now is I'd like to move into a discussion on the Internet of Things. So this was just a recap of that. And just a reminder over here of how we have the infrared light coming from our sun in natural light. And so what that does is we get the heat because of the infrared, because you would have noticed that even though your light varies indoors, that doesn't necessarily relate to a change in temperature. So what is Internet of Things? Because that's what we're going to be working with today. Today, we're going to be focusing very much on building our dashboards. So I'd like to actually just explain all of this to you. There's also another thing that I have to say is that I have had such incredible allergies the last few days. So if I've got a slight sniffle, it's because of my allergies. It's not because I've got some kind of a drug problem. So I just want to put that out there. Okay, so Internet of Things. How does this whole thing work? So what it is your X chips that you have here, these little chippies that you have, these are the things of Internet of Things. So what we have is, let's actually just start here with step number 1. So these IoT devices, you can see there's a number of different examples here. So here we've got this little thermometer. So this is, let's say, for example, your temperature sensor. This is your humidity sensor. Sometimes you can have a camera, which is, it's taking pictures, or otherwise it's absorbing light. So we could actually swap that out and say, okay, that's actually our light sensor over there. So you've got all of these different inputs. So remember what we did is we said we need 4 elements when we build a circuit or when we build an instrument. We need an input, an output, a processor, and power. So our inputs are over here. What we do is we have our inputs in terms of our sensors. Okay, those inputs then go to our core. And in this case, what you do is you have the CW01, so it's our core Wi-Fi 01. So what it is that there's memory on this core, and what it has is it has the Arduino code loaded to it, and so we used the X-in-a-Box uploader to load our Arduino code, which in this case we called UNDP STEM. Okay, so we have our code there, and so that input is being converted, and it's saying, right, I'm getting an input of data, and what I can do is I convert it. So what it does is that Arduino code, it converts it to two types of output. The one is to our OLED screen. Okay, so the one is to our little OLED screen, and the other input goes via our little Wi-Fi antenna that we have here on our core. So what happens is that Wi-Fi antenna transmits, that Wi-Fi antenna transmits via using Wi-Fi to the internet. So that is why it's really important that in order for your kit to work, you actually need to be connected to the internet. So you need to connect it to a Wi-Fi router or to maybe a hotspot on your phone that has access to the internet. So what it does, it goes via the internet, and then that step 2 is it actually goes to a data center. So what we have as X-in-a-Box, we have a data center that's running in the US in a data farm, and that is referred to as an MQTT server. Okay, you don't necessarily need to know the intricacies of the MQTT server. However, MQTT, that is the technology that is at the core of Internet of Things. So what happens is that the data comes from your sensors, goes via the Wi-Fi, via the internet, and it goes to this data center. And what happens is that data gets saved there. And what it does is that every 10 milliseconds, okay, so that's 100 times a second, your little sensors are posting data, and it just gets saved there. When you have internet connection, it just gets saved there on that server, okay, it just gets saved. Then what happens is, if you want to access that data, what you do is you call that data, and that is the specific way that an MQTT server works. Okay, so what it is we posted it, and we're keeping it all in a repository that we call the weather station repository. And I'm going to show you that later, that we've got all of these various repositories, but remember it's weather station repository where yours is. And then what can happen is when you call on that data using your device name, what it does is then once again via the internet, it then shows it to you, and then it displays it for you on your screen, on your dashboard. So what it is that the Internet of Things is we collect the data at our devices, which is our X chips, via internet to the server. And then when we call on it on our dashboard, it then comes back to us also via the internet. Does anybody want to have some input there? And I'm specifically calling out here to Brittany and to Colin, if you want to come in and please add to this.
That you gave a lot of information, and I feel like your explanation was amazing, Judy. Thank you. Basically, just to simplify what you said for the students, as my understanding of what IoT is, you can think of it like a sort of broken telephone of sorts, but not broken. It actually works. So you have your input from your environment. That's the initial message that would come from your sensors, so your inputs. And then your processor is the brain of your device or circuit that first sends the message to your LED screen, but then also sends some data to a data center that controls and keeps all of that data for you to pull from that. So think of it in a way like your CW1 on your device is acting much like your cell phone. So when you would send a WhatsApp message or something like that, it doesn't go straight from your phone to the next person's phone. It goes somewhere else first, and then it gets pulled from that main source of information to where you want it to be. Kind of also like the way libraries work. Like in real life, different people would write books, they put it in an actual library, and you'd go and look for the book that you want and go and get that, and then put it back when you're done.
Yes, Brittany, very good an analogy. Yes, please, Colin.
Yeah, hi everybody. I think both Judy and Brittany covered it very, very adequately. But I think maybe I just want to mention that the fact that it's called the Internet of Things really is the ability to connect a whole bunch of things together. And you'll also find that we're currently living in a world where we have a physical world, a physical environment, and a lot of people spend a lot of time today converting the physical environment into a digital environment. Now, a lot of you, I know, play games like Minecraft and Fortnite and that type of thing. And so you spend a lot of time inside a lot of these virtual worlds. So if anything, what's happening from an IoT perspective is that it's connecting the physical world into the virtual world. Some of the new concepts, from a corporate environment perspective, you'll hear a lot of people talk about things like a digital twin, right? So if you look at a mining type of situation, because of IoT, you now have the ability to connect your entire mining operation and put it onto a screen in front of you. So you're able to connect all the bulldozers and all the machinery running around in a mine. You're able to connect and collect a lot of information around the environment, whether it's temperature, mining again, air quality becomes a hugely important factor to collect information. And all of this data is then stored. Judy referred to it as the data center. A lot of the information is then stored in a central sort of area. And you find we now have the ability to analyze all of the data that's collected. And it's not only a one-way direction, we have a two-way direction, as well. So we can now say, okay, great, because my particular mine has an issue around dust. Quickly, can we go and turn on some fans and blow the dust out? Or I'm using a very trivial example, but it's something like that. And then the other point, just before I hand across to Brittany, is just at least from a career standpoint, you'll start to find that there are so many corporates out there today looking for IoT skills. So in addition to your STEM background, it's also great to have exposure to IoT. So it's unlocking additional professional opportunities for people that sort of move in that direction. Brittany?
Thank you, Colin. I just wanted to draw attention to what Lisa said in the chat. From his understanding as well, it starts from the device, the X chips, then sends it on a path with the data stored in packets, which go to the cloud or internet, where it is stored and where the servers call for that data and is stored on the server. Then the data server can send instructions to the internet where the X chips receive those instructions. And that's a very good understanding, I think.
Absolutely, totally agree. That's very, very well put, Reza, as well. I think you summarized it quite nicely. But yeah, so ultimately, just like we have, I think, to summarize the terminology, Internet of Things, if you look at the history of the internet, and the internet that we use today, right? A lot of you use it for social media, and we use it for, today we're using it for learning, right? We're connecting with each other and conducting these types of courses, etc. So back in the day, computers were not really connected together. So they tried connecting two computers together. It actually goes back to the US military and the Department of Defense. And eventually they developed this really nice interconnected network of computers, and then it was handed over to the universities. The University of Berkeley got involved, and the universities got really excited, and they said, wow, we can now start sharing information amongst us. And then eventually we got some really interesting guys like Tim Berners-Lee that sort of brought about HTML, which is kind of the language of the internet. So you can very quickly see how that evolved. And we're starting to see the same thing now, just as we saw happen with computers, we're starting to see it happen with things. And again, things could be absolutely anything.
Yeah, and just to carry on with what Colin was saying about the Internet of Things, things doesn't necessarily only need to be your phones. More and more often, a lot of things are being connected to the internet. And I speak for myself as a fellow Gen Z student, as many of the students in this, a fellow Gen Z person, as many of the students in this program are. We've become so accustomed to most things just being interconnected that you being able to learn Internet of Things as a subject and as a skill really gives you a better understanding of how to utilize the tools that are available today, because so many things are starting to become interconnected on the internet, because we've come to a point where all of the information can be found in one place, and we are in a sort of information age. And that's where all of this comes in. So more and more often, not only our cell phones and computers are connected to the internet, but things like watches, fridges, more and more often, more and more things are being connected to the internet, because we've realized and we've come to a stage where we want all of that information so that we can use it to make better decisions and to automate more things. So Internet of Things is not only sourcing information and getting that information to and from different places, but it also allows you to use that information to automate and do things remotely, but also to make better decisions. And it connects, as you'll see going deeper into the program, really much into things like machine learning, artificial intelligence, and robotics.
Great. Marvelous. Thank you, Brittany. And thank you, Colin, for that explanation. So what I'd like to do is, let me just share again. Let me just show you here. So yeah, thank you, Brittany. You've put it in the chat when we start accessing our dashboards. So thank you very much for that. We're going to want that information. So I want to show you what I've been up to this week. So what I did is that I'm participating in a global challenge called the Hot Chili Challenge. And what it is it's a global group that started actually on Facebook, and it's grown like way beyond just being on Facebook. So and this comes from the fact that on the International Space Station, the astronauts over the last probably 2 years, they've been trying to see how they can grow food in an artificial environment, because what we need to do is we need to plan that since we're going to be having a lot more people in orbit around the Earth, also we're going to want to be able to go on missions back to the moon, and we want to go to Mars. We need to be able to grow food, because we can't always take the food with us. And so what they found is that when they grow food in an environment where they don't have a lot of natural light, where there's a lot of artificial light, the food has very little taste. So there's become a realization that there's a relationship between sunlight, natural sunlight, and the taste of the food. And and the thing is that what is happening is that a lot of botanists and a lot of biologists are saying, we told you so. Yes, we were absolutely right, because a lot of them will say it's not only about the soil that you grow the food in. So, for example, there's a whole thing around making Italian food, is that it needs to be a very, very specific type of tomato, and it's always better if it's actually grown on the slopes of Vesuvius, which is quite close to Naples, southern Italy. And the thing is that a lot of what people have been saying over the years is it's got to do with the soil. The taste of those tomatoes is because of the soil. There are other botanists who've been saying it's also got something to do with the light. And so now what we've discovered is that if we actually make sure that the soil type is exactly the same, but we change the light conditions, that really has a huge impact as well on the taste. So what has happened is that whenever they've tried to grow chilies on the International Space Station, it's turned out that they've had absolutely no taste whatsoever. So what's happening is that that specific enzyme that gives that taste, that chili taste, which is measured on something called a Scoville layer, but a Scoville measurement. But I don't want to go into that right now. That's like highly technical. But the thing is that what's happening is that enzyme or that particular molecule is not being created unless there's a lot of natural light. So what I did is that much earlier this year, I started growing some chili plants, and they were paprika plants in my office. So it's inside. I've got a film over the window, so it blocks out a lot of the ultraviolet light, but not all of it. And I found that that paprika, those paprika chilies that grew actually did have absolutely zero taste. It was like absolutely amazing. They didn't even taste of vegetation. They had no taste. So what I've done is I've started now where I've got two different types of chili. So I've got a cayenne pepper and I've got a paprika. So what I did is that you can see here on the 14th, which was 4 days ago, what I did is that I planted them on exactly the same day in exactly the same soil in the same pot. And what I did is that I completely saturated the soil. So I was starting off with exactly the same humidity, soil moisture as well. And what I did is I then put together my, I was meant to go actually to the side over here onto the right-hand side of the screen. So what I did is that I put together my kits. What I did is that I just used a few blanks. So don't worry about those. Those aren't sensor boards. I just put them in because I wanted to connect a micro USB instead of the normal USB. So don't worry about that side of it. But you can see here I've got the CW01. I'm using this particular light sensor, the SL01. I've got this blank in here. I've got my SW02 as my weather sensor, and of course my soil moisture sensor. So what I've got is that I've got these two kits that I'm running. So I've got two identical kits, and then what I have is that I have these two different pots. And so what I'd like to do now is I'm going to stop sharing the slide, and I'm going to show you the dashboard that I built to compare these two so that you can see the value. There we go. I think you can you see this? Can you see this screen now? Okay, so here we go. Now we have the different ones. So I'm calling them my chili comparisons. So if you were to go to the dashboard and you were if you were to go to this tab here on the right-hand side dashboard and you were to search for that, you would be able to see my dashboard. Please don't edit it or anything like that. So I don't mind if you save it as your own dashboard by changing the name, but you need to save it as your own dashboard or as a new dashboard if you want to fiddle with it. Please don't fiddle with mine, because then I'll just have to rebuild it from scratch, and that's going to be not great. Okay, so what we can see here is we've got these pot plants close to each other, so we can see that it's tracking quite nicely. This top graph here I have is where I've got soil moisture, and then I've got relative humidity in the room. Now the thing is that I'm right at the coast, so my relative humidity is high, pretty high in this room, which is okay. And also if we consider that that weather sensor is very close to the soil anyway. So it's probably as the moisture from the soil evaporates, it's probably passing that sensor anyway. So what I've got is I've got this going back. You can see up here last 4 days. So I'm tracking the last 4 days. You can see this is when I turned it on, was all around 5 p.m. And so this has been the peak of the sunlight has been here at 10 a.m. on that particular day, 10 a.m., 10 a.m. and once again at 10 a.m. So what I have is that as the sun moves over across the window, it's coming directly in, so that they're being hit by sunlight there. So that's the lux levels that I've got. Then what I did is that I separated out my soil moisture. And you can see here in this top graph, it's 0 to 100 in percentage of soil moisture percentage. But here what I've done is that I've zoomed in on it, where I've said I've got my minimum as 75 and my maximum as 95, because I want to be able to track it. I want to be able to see if the moisture gets too low, then I really want to be able to rectify it, because that'll be a trigger for me to water the plant. But look, isn't this absolutely amazing? What I've got with the paprika is I've got it at this particular period over here, the lowest it went to was 83%. And look at what's happening over here at the same period. It's in the 70s. It's around about 77%. So that's actually quite interesting. What we can also see here is this cane chili is getting a lot more light. So it's just so interesting, because they're right next to each other, but just moving that, I would say, they're like 20 centimeters. The center of the pots are about 20 centimeters away from each other. And suddenly we can see a huge impact here on the light that it's receiving and how the soil is drying out in the process. And here we've got temperatures. And so we can see, at 10 a.m. every day, we've got a peak in our temperature, and then it comes down. And then, what is this? This lowest point here is 6 a.m. Okay. And so, we can see that it's tracking very well with both of those. And so what I've done as well here is that I've got it from 0 to 40 degrees centigrade. So what I've done is I've kind of like hard coded that in, so that I make sure that I can see that they're tracking nicely. They're tracking nicely together. And then of course I've got the data tables. So I'm going to open it up now. If anybody I'm going to keep sharing this. If anybody wants to make some comments or remarks or ask any questions on this.
Hi, Judy. Liam was asking where he can get the graph he wants to use it. So just, if you mind, just showing them one more time where to find it.
Okay, Brittany, I'm sorry, before I navigate away from this, is it okay if we can just discuss the screen that we're on before I get into the nitty-gritty? Colin, I think you were waving. You also wanted to say something.
Yeah, hi, Judy. I just want to ask the question. So just to understand, the contest or the challenge is looking for who can grow the hottest chili, right? How would you actually measure? You mentioned that the scale is Scoville. How do we actually measure the hotness of the chili?
Yes, Colin, that is actually something, and that is with this global challenge, that has also become the next part of it. Is how do we actually quantify it? So the thing is that right now what we have is we have people simply just eating the chilies and seeing how our bodies react to it, but there is definitely a method, because the enzyme or the molecule that gives that taste can actually it is a molecule in itself that can be determined if we were to send it to a laboratory and they were to be able to single out that. So, and then, yes, the concentration of that is measured on something that's referred to as the Scoville scale, because it was a scientist by the name of Scoville who actually identified that particular molecule. So probably what would happen is that the chilies would go off to a lab, and then the laboratory would decide on a common process to actually perform, to be able to compare the data. And a lot of the time what happens is that it's a light spectroscopy that would be used. So every molecule, what it does is that every molecule almost has a unique fingerprint, you could say, because of the different chemical bonds that it has. So while I explain this, let me actually just stop sharing so that what I can do is let me explain this from a chemistry perspective. So when we have two atoms and there's a bond between those atoms, that is our chemical bond between the two atoms, and then a number of atoms make up a molecule. So depending on the combination of atoms that you have, it also affects the exact type or energy in the bond that you will have. So if we have let's take a diamond. We all know that diamonds are incredibly strong and incredibly hard. And that is because of the carbon-to-carbon bonds that we have. And what it is that there's 4 available spots on each carbon atom. And what it is that in a diamond, there's this wonderful matrix that forms between those different carbon atoms. And those carbon-to-carbon bonds are the strongest that we can find. That is why a diamond is so strong. Then let's say we take, for example, the bond with oxygen. The oxygen that we breathe is O2. So what we have is we have an oxygen atom, which has 2 available ports, and another oxygen atom with 2 available ports. So what it does is it creates 2 bonds. So it's like a double bond, an oxygen to oxygen double bond there, which is very, very strong. And so what happens is that the energy is retained in those bonds. And when we break that bond, what it means is we have to apply that amount of energy to break that bond. So let's go back to, let's say now, this molecule that gives the chili taste. I think it's called capsicum. I think the common name for it is capsicum. That's where the capsicum comes from. But anyway, what that is that's going to be a combination. It's a hydrocarbon. So it's going to be a combination of carbon and oxygen and hydrogen, and maybe a little bit of that gives it the taste. So there may be a bit of nitrogen, there may be some sulfur, something like that. But it'll be a large, complicated molecule. And what will happen is, in order to break those bonds, is a very, very specific energy level, which will then relate back to a very specific light wavelength or frequency. And so what happens is that when we have a very hot chili, like maybe what would be a hot chili?
Bird's eye chili or a...
Bird's eye chili, great idea. Bird's eye chili. We put the bird's eye chili through, and then we'll have this huge peak when it gets to the capsicum, okay? And then if we take something that's very mild, like maybe let's say a normal red pepper, like a normal red bell pepper that's not hot at all, then it'll be a little blip there in that area. So what we do is we measure the difference in those peaks. So you can see that everything relates to everything else. What we've got is we've got light and we've got chemistry, so we've got physics and all of that. And there's always an explanation. If we always break every question down to the fundamentals of physics, we can always make sure that we can explain it. So yeah, Colin, I hope that is enough of an explanation of how would we know how hot the chilies are. What it would come down to is what wavelength of light does it absorb. So yeah, Brittany.
I have a question. Are there other people in the hot chili challenge doing the experiment the way that you are? So simulating like inside, outside, and shade, etc., with exactly the same set of variables and measuring it in the same way that you are, or to the best of your knowledge, are you the only person doing that?
No, I'm not the only person. I'm not the only person. So what it is that these kits that we're using, we've been sending them out now for probably the last 18 months. So there's schools all over the world who have these sensors, this combination of sensors. And so, yes, there are a number of experiments that are being done around the place. And Brittany, I know that you are currently training and mentoring a group in California who have the same kits, but I'm not sure if they're at this point yet where they know how to use their soil moisture sensor or something like that. So certainly the group that we have together today definitely is ahead of that group, probably like maybe 1 or 2 weeks ahead of that group. But yeah, so the thing is that what it is in terms of the challenge, there are a number of people who are using very different light sources. So what they've got is that they've got ultraviolet lamps, or they've got infrared lamps in a basement, and different combinations that they're trying to see how they can grow their chilies. So yeah, it's turning into quite a lot of fun, actually, the way different people are trying different things. Absolutely. So what I'd like to do is we've got 6 minutes before the break. So let me go back to what I'm going to do is that I'm going to take you through how you get onto the dashboard, so that what we can do is over the break, you can experiment a little bit and we'll be around to answer your questions. So if that's okay, may I do that, Brittany? Are you monitoring what everyone's saying and feeling? Okay.
Yes, there are some technical questions. So I think it would be great. I've made a few different breakout rooms. So for those who have technical questions after Judy's done, please join the troubleshooting breakout room. And then there will be a breakout room for tips and tricks for Kibana. And if you want some more tips and tricks for Kibana, join that breakout room.
Great. And Brittany, I just want to know if, are you going to, do you want Bianca to step into that other breakout room? Okay. Right, I will let him know. I will call him. So you need to give him about 5 or 10 minutes to join, if that's okay. So let me go back to sharing my screen. Okay, so I'm going to share my screen again. And what I'm going to do is, let me just go over here. So I'm going to go all the way back again, and I'm just going to say data.exinabox.cc in my browser, and that's where I'm going to go. Now, because I have logged in here because I've logged in here before, it's already saved the username and password. So the username is the first part of that domain, which is data. And the password is X in a box. And please, it's all lowercase. Now, the thing is that what this is this is a very common dashboard. And so this is being used by students all over the world. Okay. So remember earlier, Brittany mentioned the idea of if you were to, she used the analogy of a library. Okay, so she said somebody writes a book and it gets put into a library, and then somebody else goes and then collects that book to read it. That is exactly how this MQTT server works. And what you could imagine is that if you want to go and take a book out of a library, you need to know which shelf it's on, right? It doesn't help that you arrive at the library and the librarian says, I have no clue. You're just going to have to look along every single shelf to find that book. That's not the case. There's a method of classification. So what the librarian can do is they can say, oh, that book is going to be in the non-fiction section about physics, about et cetera, so they can actually tell you exactly which shelf of which bookshelf that book is on. And that is exactly the same. So you can see here, let me actually just zoom in a little bit. How about that? So let me zoom in even some more. And so what we can see here is that it's defaulted, as soon as I arrived, it was default to the weather station index, okay, or otherwise the weather station kind of bookshelf. We refer to it as an index in MQTT, okay? And so the weather station index, that's where it's defaulted to. There are other indexes, okay, but you're not going to worry about these other indexes. But just to show you that we have for the International Space Station, there's one for the specific project that we did this year, but that's going to be merged with that other one. The solar eclipse that we went through a number of weeks ago, that was on this particular index. These are our satellite kits that we've put together, etc. So we are only concerned with weather station index, so you don't have to worry about changing that index. Then you can see here, it says here count. So this is actually telling you how many kits are connected at any one time, okay, and how many data packets are being received from kits all over the world that are posting to the weather station index. Okay, so now if I want to see if my kit is connected, what I need to do, and I just need to move this out the way. What I need to do is, and I need to put it into the search bar up here. So I called one of my kits Paprika. So all I need to do is I just need to put a few letters in, P-A-P-R. Oh, why isn't it typing there? P-A-P. This is so weird. I'm not able to use my keyboard. Okay, that's working. Okay, let me just put in there P-A-P-R and then hit the search bar, and you need to keep that little star or asterisk there. And so what it'll do is now it's just going to search, and now it's come up with mine, and it's saying, yes, we've got something that relates to that. That's Paprika.js. And so it is there. And what I can do is, you see this little arrow, I can actually open that up, and then I can see here, this is the data that is coming through. So it's saying, okay, I'm using a CWO. Don't worry about whether it says 1 or 2 there, that doesn't really matter. So I've got a -78, which is actually relates to the strength of my signal. That's my unit name. I'm using the SL01. I'm getting a lux reading there. I'm using the SW02 sensor on this one. So I'm getting a relative air humidity of 48. That's my air temperature. That is my atmospheric pressure. And that is my soil moisture at 91. Okay. Now it's very important that you note this, okay? Because when you start building your dashboard, you need to relate it back to exactly which sensor you have here. Okay, so what I'm going to do at this point, we've just passed 12. So I'm going to stop sharing. Brittany, if you want to have everybody go into their breakaway rooms, I'm quite happy to carry on with tips and tricks with Kibana. So how do you want to take it from here over this break?
I made a dashboard tips and tricks for Kibana breakout room. So possibly you could join that, or I could delete that room and you could remain in the main room. And then there is a room for assignment questions that I will join in the second half of the break. So in the second half an hour of the break. And in the first half an hour, I will be in the troubleshooting breakout room.
Okay, so what I'm very happy to do is if you're going to be in the troubleshooting for the first half of the break, I need to go and connect with Bianca to get him into that room. I need to invite him and everything else. And yeah, and then what I will do is I'm quite happy to do tools and tricks with Kibana. And then you said there's a third room, and that is called?
Assignment questions.
Okay.
So if anyone has any questions about the assignment, because I know from Lisa's submission, he had a few questions. So any feedback, any questions before anyone submits, further, if they are unsure, I'll answer the questions in that.
Okay. Okay. So let's do that maybe after 12:30. That room, you mean? Okay. Wonderful. Okay, so I will be back in, let's say, 5 minutes, and I'll come into that room. What I'm going to do is I'm going to pause the recording now, and then I'm going to start it again when we start the main session.
Okay.
Great. So thank you, everyone, for coming back after the break. And before we start our discussion about robotics, are there any questions from anybody or anyone want to make any comments?
Yes, Judy, there's a question that I got, a direct message. It's about troubleshooting. Will there be a troubleshooting session on Wednesday again?
If necessary, we will.
Yeah, because well, one of the students, Nandi, didn't get to go to the breakout room for troubleshooting, and she's explained her issues. I've given her a suggestion, but just in case that doesn't work, will there be a troubleshooting session on Wednesday?
Honestly, we hadn't planned for one because the catch-up session on Wednesday is it's going to focus solely actually on the robotics projects. And we actually have what I was going to mention was a little bit later, but I may as well mention it now, is we have a guest speaker who's going to come in on Wednesday at 5 p.m. Into our session, and that is Carl Schumacher. And Carl Schumacher is a well-renowned and international, he's actually an international photographer. And what he's going to be doing is he's going to be doing a session for us that is really all about how to take a really good profile picture of yourself, a more kind of like professional academic style profile picture of yourself. Because the thing is that what we're going to be doing is when we do our projects relating to the robotics, etc., you may want to actually have a really great photograph of yourself. And so it's going to be about how do you use your smartphone to take a really good photograph. So Carl is going to be helping us with that on Wednesday. So yes, I've been able to book him for that session. So that's at 5 p.m. on Wednesday. Yeah, we haven't had many people come into those catch-up sessions. So the plan actually was that we would only do between 5 and 6 on Wednesday. Perhaps if there is a requirement for some troubleshooting, then maybe we do that before 5 o'clock on Wednesday. What I could do perhaps is have Bianca join. Maybe Bianca can actually host a troubleshooting session. Yeah, it's getting very close to the end of the program to still be doing troubleshooting. That's my only worry.
I agree. And then somebody asked, will the session on Wednesday be recorded as well?
Yes, definitely. Definitely Carl's session on Wednesday is going to be recorded. We haven't recorded the other two catch-up sessions because they've been very open and unstructured. But Wednesday's session is going to be very structured, definitely between 5 and 6 p.m. So we're definitely going to record that one.
Okay, awesome. Thank you, Judy. That's all from the chat.
Okay, that's terrific. Okay, so what I'd like to do is that I'd like to get back to our robotics projects. So who was able to see the email that I sent out? I think it was probably in the last 2 days about the awards that are up for grabs for robotics ideas and robotics projects. Okay, so Tafara, I don't know if you want to turn on your microphone or your camera and actually share with us. So what was that all about?
Hello.
Hi, how are you doing?
I'm good, and you?
Good, thank you.
Good. So after I read it was a Word document from you, obviously. So it was basically what we were talking about and the ideas people pitched in last week, Saturday, I believe.
Mm.
So one idea I remember is from Riza Kluter.
Mm.
He said something about having a robot that can detect the moisture and then send it back to a mechanical system, if
Yes.
I'm correct. Then
Yes.
there was also another one where the top 3 ideas will receive a prize.
Mm.
And I remember there was top 5 from the quizzes. So all the experiments and quizzes all together. The top 5 will receive a certificate, if I'm not mistaken.
Yes. Actually, everybody who completes the program gets a certificate. The top 5 participants who get the top 5 scores, certainly there's going to be an award from X in a Box. And then what we're also looking for is we're looking for the top robotics ideas submitted, one for each of the Sustainable Development Goals. So goal number 7, which is affordable and clean energy. So that involves whether it is solar power, wind power, or water or wave generation power. The second Sustainable Development Goal is 13, which relates to climate action. And that is a lot about greenhouse effect, etc. And then the third Sustainable Development Goal and the third award that's up for grabs is Goal 15, which is life on land. And that really relates a lot to our soil moisture and those kind of conditions on land. So yes, what we're looking for is we're looking for 3 submissions, one for each of those Sustainable Development Goals. And the way you're going to submit your idea is by making a video. Yes. So what I'd like us to discuss is some ideas, please, on how could we make a video and submit that video. So any suggestions or ideas around that?
If I'm not mistaken, one point on the video, it needs to be at a certain time span. I think 1 hour, 1 minute, if I'm not mistaken.
Yeah, absolutely. So it needs to be very short and very sharp. Yeah.
Okay. And when it comes to pitching an idea, right? Can you make it so you spoke about the 3 points, the 3 Sustainable Development Goal plans. Let's say you have one idea that covers all of that. is that possible that you can pitch, or it needs to be separate, 3 different ideas?
Just pitch it, and then what you do is you enter it for each one of those. That's absolutely fine. You can have one idea that spans all 3. You don't have to pick. That's absolutely fine. So anybody with ideas regarding how would you practically actually make your video?
Judy, can I please ask, does the video have to be only about your experiment, or can it include a little bit of background information of the problem that you're trying to solve?
Melinda, that is a great question. So what I'm going to do is I'm going to share my screen quickly, because these are the questions to be answered. What is the job we want the robot to do? Why would we want that? What would be your inputs? What would be your outputs? So I think that when it comes to what is the job that we want the robot to perform, there will be some background regarding that. Since the submission needs to be maximum a minute long, I think that one needs to be careful just how much background you actually want to cover in that. The judges are all specialists in the Sustainable Development Goals. So you're not going to have to teach them as part of the video. They do already come with a very strong background. Brittany, I think that your hand is up. I'm not sure. Sorry, I can't see anything when I'm sharing my screen.
Yes, my hand is up. Basically, some advice that I'd give in terms of the 60-second video with my experience for hackathon submissions. You'd want to have what's called like a power pitch or an elevator pitch. So think of it like when you get in an elevator, you have like roughly 15 to 30 seconds, maybe maximum a minute with this person. So think about it this way: if you were in an elevator with Elon Musk, Steve Jobs, any of those people, how would you best get them your idea in those 15 to 60 seconds? You try and hit like an overview of your main idea, a little bit of background, just enough to give context, and then how to sell it. And essentially what I've seen work so far has been having some element of some slides and some narration and keeping it very high level, but still concise.
Definitely. You could certainly do that. And so the thing is that, yeah, Brittany, as you say, what you want to do is you want to be able to hook your audience so that they pay attention to what you're going to say. And yeah, I think let's just go back to those questions again that you need to answer, and how do you frame it? So yes, what is the job that the robot's going to perform? Why is it going to do that? Why is all around, it's going to help improve the environment, it's going to help save on carbon footprint, or it's going to cost less, whatever it may be. And then, yes, very importantly, what are the inputs? What is the input data that you're going to have? And then what is the output? In other words, what movement is the robot going to perform, or what action is the robot going to perform as a result of receiving that input? So the thing is that based on these ideas, what we're going to do is that we have some code developers who've been developing the code for you that you use in X-in-a-Box Uploader. So what we're going to do is we're going to take those ideas and we're going to have them translate that into code, so that you can actually then start building your robots after that deadline of the 30th of September. And so is there anybody who maybe wants to suggest what they would have in terms of their ideas and how they would frame it?
There are a couple of ideas in the chat already, but Denise just asked, must it be an idea that you can execute yourself with what you have, or an idea that you can need more parts and help for? So just to clarify, I speak under correction, Judy. It can be an idea that you may need more parts and support for. It has to be your idea, right?
Absolutely. Yeah, I mean, there's going to be a limit to the number of parts. I think that if you go to the X in a Box website, you can have a look at the various components that are available. So, and the reason why I say that is it would be limited because, for example, we don't do any water monitoring sensors. Like we don't do any sensors that are going to get wet, like pH levels or suspended solids or, you know, metals in solution and that kind of thing. So we don't do any of that, you know. So, and that's really why I'm kind of like, I'm saying it's limited. What I would much prefer is that you restrict your project so that the inputs are the sensors you actually already have with you. If that's okay. Yeah, Brittany.
That does link to a question Unati just asked. Do we need to link input with the X in a box, or can we think of something else? So I think you just answered that question. Try and limit yourself to using the sensors, inputs, outputs, all in the X in a Box ecosystem. I'll drop the link to the X in a Box website with the chipset in the chat now.
Okay. That's absolutely great. Then we have another question from Karine. Should the first two assignments be in essay form and include dashboards? Karine, I think, are you referring to these next two that we're going to be doing?
She's referring to experiment 1 and experiment 2. So the relationship between light and temperature, and then the next one as well. For I think it's daybreak.
No, I think it's the does the light go off in the fridge?
Oh yeah.
In fact, all three of them. This first one that we've done doesn't need to include a dashboard actually, because the first experiment is where you collect the data and you read it off your OLED screen and you do your own table and you draw your own graph. That is the relationship between natural light and temperature. So that assignment actually should already have been done. And for that, certainly you don't need to have the dashboard. It's for the next two that you're going to do from today to the end of the month, which is does the light go off when I close the fridge door? And also, does it still get colder after daybreak? With those two, you will need to have your dashboard up and running.
And then we just got a question from Liam. Can I use this as my project where after you wash your clothes, the water filters through a pipe, and when the SW7 detects that the moisture is low, the pipe lets the water through and activates a sprinkler?
Okay. Liam, what it is it's a soil moisture sensor. It's not a water flow detector. Is that?
I think what he's trying to say is you'd collect the grey water somewhere else from washing your clothes, and then you'd use the SW7 in the soil as a sort of input to see whether or not you have a certain level of moisture in the soil, and then you'd have some sort of other output that will allow the pipe from your grey water tank or whatever to let off a sprinkler to wet the soil.
Absolutely. So what you would do is you'd have some kind of a valve or a tap on that pipe. And then what you would do is you would either use you'd use one of your outputs. I don't have them right here with me, which is the OC01, which is really what that does is that you would use that for a DC switch. So that would actually, that would have a switch like you would have a light switch or whatever. You could actually, it would turn on a motor to open your valve, or otherwise you would use maybe your servo controller, your OC05, and then that could actually open a valve for you or close a valve. Definitely.
And then we have another idea from Tendai earlier. We could make a robot to ascend to Mars and check the weather there. And he also said earlier we could make a robot that uses solar energy for the water system. I don't know if he wants to unmute himself and describe his idea in a bit more detail so we can give him some more guidance. Tendai, if you want to unmute yourself. While we wait, Riza just sent into the chat the two ideas I sent was one for a rover that works with plows, waters, and gives information about the crops such as soil moisture. And my other idea was one that controls the various sensors that give instructions, for example, to move a solar panel or turn on sprinklers. So Riza, if you perhaps want to unmute yourself while we wait for Tendai, just to talk through your idea so we can guide you.
Hi everyone again. There we go. Okay, so the idea that I sent through the email was, hold on, let me just open up the Word file quickly. Okay, was for the first one, the rover, which works on the crops and is basically able to take information about the soil using where's the chip now? The soil moisture sensor, and where's this other one? The SW02 and SL01 to take information about maybe what time of day it is, and then be able to tell when to water the crops. But it won't water the crops, for example, if it had rained.
Absolutely. Yes, you're very right, because your SW02 will be able to give you, yes, your temperature as well as your air humidity. So yeah, your air humidity will give you a very good indication as to, yeah, how moist or how dry your air is. And yeah, your soil moisture sensor will let you know if you should be watering your crops or not, because if your soil moisture sensor is reading above 95% moisture, it actually means that the soil is waterlogged. So you know, and sometimes that can also be a challenge. You know, I mean, it's not always about too little water. It can also be about too much water, because maybe you haven't got enough drainage in your soil, that kind of thing. So yeah, that's a really good idea, is to use that. One of the examples that Bianca came up with the other day as well, during our session on Wednesday, was that what you can do is you can actually take data from somewhere else altogether. So maybe, for example, if there's a weather prediction site, you know, where they actually predicting that, let's say in the next day or two, it's going to rain, then what you could do is you could also then, your robot could then make a decision. Am I going to wait for the rain, or am I not going to wait for the rain? Because yeah, you don't necessarily want to water the crops today, if you do have access to the knowledge that it could rain the next day. Sure, Brittany, yes, back to you.
Thank you, Julie. My only concern with using SW7 on a rover is that I don't know precisely how long it takes to actually get an accurate reading. So if your rover is moving and your SW1 is moving with your rover, how exactly are you going to have the SW07 in the soil as you're moving? Are you going to be dragging it through the soil? Are you going to be moving it in and out of the soil at certain points? That's something you'd have to think about from a technical perspective. Am I on the right track there, Judy?
Yeah, I mean, you don't necessarily need to move the soil moisture sensor. What you could be doing is you could be sending the data via the Wi-Fi or via some other means. So your soil moisture sensors could be permanently in position, and then all they do is send the data. Yeah, you wouldn't necessarily need to move it.
Okay, so he just mentioned in the chat now that it doesn't necessarily need to be connected to the rover. It could be in the soil at certain intervals or in a fixed place. Grace wanted to share her idea of the Reza and Tendai. So if Tendai is not ready yet, do you think Grace can take the floor? Grace, you can unmute yourself and the floor is yours.
Thank you, Brittany. I have a very crazy robotics idea. Well, I thought it was very crazy until I heard Judy speaking about growing plants in space. Well, my idea was that of a robot that can store sunlight energy for photosynthesis. Well, plants that don't have access to direct sunlight, such as in space or indoors, or maybe for scientists in Antarctica. So that robot can store sunlight energy and help the plant for photosynthesis. Yeah, I don't know.
Brittany.
Judy, I actually think this might be easier for you to explain, because to my understanding, there aren't any components today, not just X in a box, just in general, that can store photosynthesis energy, so store sunlight. I'm not sure if that conversion can actually work, where you'd like some sort of solar panel absorb the energy and then be able to transfer it to a plant per se. I don't know how that would work. So Judy, maybe you have some insight on that.
Okay, this is off the top of my head. Let me start with that disclaimer first. At the end of the day, everything is just energy. So the solar radiation is energy. And yes, we do. We have this broad spectrum, all the way from ultraviolet on the one end to infrared on the other end. And then, of course, visible light in the middle. We know how to store solar energy, and that's using solar panels and batteries. So the incoming light, natural light, or the incoming solar energy could be gathered using solar panels and stored in batteries for later, to use later. Now what we want to do is now we've taken the light and we've converted it to energy. Now what we want to do is we want to take the energy and convert it back to light. We can do that because we have artificial lights. We have infrared lamps, so we can produce infrared. We can produce visible light. We can also produce infrared light. So what it is if we then map what exactly is the wavelength of the light that is ideal for these plants, then what we could do is then we could design a light that specifically supplies that. So then we take the energy that we've stored and convert that back to light. When it comes to photosynthesis itself, there's been many experiments of how to actually artificially produce chlorophyll. The artificially produced chlorophyll in the labs still isn't of the quality that plants just do naturally. So the thing is that there are a number of green energy plants, production plants. Excuse the pun when I say green energy, because it's not only is it environmentally friendly, but it is literally green. So what it is it uses algae, because algae has a very high concentration of chlorophyll. And so what it is quite often what will happen is that they'll have these algae, these tubes, these transparent tubes filled with algae, and then they use that to somehow harvest and convert the energy.
So the question from Kareem that I was also asking is, how will the robot transfer the stored solar energy to the plant? So how would that conversion actually take place? Would that be via like using that energy as light? So converting the absorbed energy from a solar panel to emitting like UV light, or would there be some other process?
Yeah, Tafara, hi.
Hi. So I was actually reading an article on storing energy recently, and there are many ways of storing energy. So energy comes in many ways, and that's how they taken advantage of it. For example, movement energy. So they created a pulley system where energy is coming from the sun, right? It goes from the sun and it is converted into movement energy, and like it's basically like a seesaw, for example, where but in cans. So the cans are moving up and down, and that's basically the storage unit for energy. Then from that movement energy, it can be then transferred into electrical energy using the energy law that energy cannot be created or destroyed. It can be transferred. So it can be, that's just one idea, then multiple. There was also another one where you take two lakes, right? One has to be on top of a hill, then another one at the bottom, and sun energy or solar powered energy is then transferred to these lakes, and they pump water between each other. This is hydraulic type of storage, if you understand.
You're absolutely right. Yes, you're absolutely right. Yes, the movement. That's what windmills do, is the wind moves the blades, and then it's that movement that's converted, that energy of that movement is then converted to power. Certainly, Colin, you've had your hand up.
Yeah, it's quite a fascinating conversation around, converting. I think there's two aspects here: converting one type of energy to a different type of energy, so mechanical into electrical, or electrical into mechanical. So that's one aspect. But just around the topic of storage of energy, and I think just as Tafara pointed out, there are really quite a few ways to look at storage. So, for example, how do you store kinetic energy? So you can convert kinetic into potential. A very popular experiment I recall back in the day of school was a little reel. It was a cotton reel. You put a little rubber band through that, and you stick a little matchstick at the other side, and you secure it to the other side. And what actually happens is that you twist the reel around, and what you're doing is that you're creating potential energy within the rubber band being wound on the inside. You place it on your table, and then that stored energy converts into kinetic energy by actually moving along the table itself. So, there are really some really great innovative ideas in terms of storing energy like that. For example, another green building that we were recently involved with, where we found that there are solar panels up on the top. It's capturing enough energy, but of course to store that, they utilized batteries, right? Batteries is an obvious place to store electrical energy. So during the day, collects the sun's energy and stores it from an electrical standpoint. But they also found that they had excessive amounts of sun. So they said, well, instead of the batteries, what they then did was they transferred the power into coolers that were somewhere in the basement, and they created ice blocks, right? So essentially, you're sort of storing energy within the ice blocks itself. And they utilize the ice blocks for cooling the environment and cooling the building, etc. So there are so many different ways. Another way is, I think we've spoken about it, is when you transfer energies to heat up water. And I think there's interesting experiments to carry out there where how much of heat can the water store, for a certain amount of time? Could you potentially add any other substances into the water itself? You might be able to add a few gels and a few other chemicals that have better heat retention capabilities. So yeah, I think it's a very interesting subject. I mean, we could chat about this in a whole session on its own, in terms of just the transferring of energies and the storage. But perhaps over to Milena, I guess.
Hi, I'm just going to add to what Colin said. Now, when the sunlight comes in the form of wavelengths, it has two options. The one option is to heat the material that it touches, and the other option is through the photoelectric effect to be converted into electricity and then stored in the batteries. Light, as it on its own, cannot be stored. So when we talk about storing energy, we have to find materials that absorb as much radiation energy as possible. And that's why Colin mentioned water or gels. But there is actually technology that in some places with lots of sunlight, they have these towers where they have type of sands and salts that literally get overheated during the day from the sunlight and then slowly release it at night. And in that way, they store the sun energy as heat energy. And the biggest problem at the moment with storing sun energy, why we don't use it in mass production, is the solar panels. And that is our challenge at the moment that we in this course are solving. How can we take the sun's energy and being able to utilize it the most through the use of solar panels, by moving the solar panels, maybe by creating better batteries that can store it. But ultimately, it's the sun's energy transformed into electrical energy. We cannot store sun energy in the form of sunlight as waves. It has to be transformed either into heat energy or electrical energy. And this is where we have to get in that direction. Thank you.
Great, Brittany.
Just to bring it back to the question that Karine and Grace were asking, we got really deep into getting the sun's energy and storing it and where it could be converted. But where it's lost in translation is how that would translate into the project. So what Grace was essentially trying to find out was how we would collect that energy, which was answered, but then how would we get that to the plant? So just to go back to that, as we mentioned, we'd use solar panels in the case of X-in-a-Box tape, store that energy, and then through one of our output sensors, possibly the OCO3, the switch, turn on UV lights to to shine onto that plant, just so that we fully go full circle and answer the question that was asked. Judy, if you have anything to add on that.
Yeah, you're absolutely right. Alia wants to share an idea. If you wouldn't mind, yes, please do.
Good afternoon.
Hi.
I was thinking about for my idea, we could build something to test the toxicity of water. So it could be something like simple, like the SW07 and the OD01 chips. It could be something like that. So we could like put water in a cup and test it with those two chips. And on the 0D01, we could it could have a number there that would tell us whether the water is safe enough to drink or if it's not clean, and we would get sick from it.
Okay, I must say the idea of testing the toxicity of the water is a really good one. Unfortunately, we won't actually get an indication of toxicity from that sensor, because that sensor has specifically been designed just to only to measure soil moisture. So it's been developed to actually put into soil, not actually into just pure water. And it's not going to give you an idea of whether there's toxins in the water or not. So I think with these specific chips, you wouldn't be able to do that, but it is a very good idea to be able to have something that could then calculate that and then, as you say, display it on your little OLED screen, so you could actually put it in and you could have a look and see. Yeah.
Tahira wants to share her idea as well. So can Tahira have the floor? Tahira, the floor is yours.
Hi. I still have to do some more research on my idea, but what I basically thought of was to use the soil moisture sensor to basically measure the moisture levels in different soil in different areas to see which areas are more prone to sinkholes than others.
That is a fantastic idea. That is a really, really, really fantastic idea. Yeah, I think that in terms of your research, yes, to see what the correlation is between soil moisture and sinkholes, because I mean, there's definitely a correlation between quicksand and soil moisture. So yeah, I think that's a really, really good idea from a safety perspective. And also there are definitely areas inland, you know, in the areas where there are old gold mines, where unfortunately there's way too many sinkholes. So yeah, I think that's really worth pursuing. I think you should do that. Yeah, Colin, I see you have your hand up.
Yeah, sure. I just want to actually add some more ideas around how to use the soil moisture sensor, right? You'll find that a lot of the sensors, they may have a primary usage. For example, soil moisture to tell you what the moisture levels look like in soil, etc. But you can actually look at applying it slightly differently, right? So for example, you can use it, you know, typically when you have a geyser and the geyser bursts, and then just below the geyser, you then have a tray. Using the sensor placed in the tray, and if the water now suddenly fills up into the tray, you can detect if, for example, your geyser has burst. Right. You could also utilize it, you know, think about, you know, filling up a bucket or a tub of some sort. And a lot of times where someone opens up the tap, fill up the tub and they completely forget about closing it again, you might have the sensor somewhere at the bottom that can detect if that's now overflowing. Just talking about sinkholes, and I'm thinking about particularly boreholes and wells and that type of thing. You've also can utilize the sensor to detect, if the water has risen to a certain height or the water has then dropped below a certain height. So yeah, you could potentially utilize it wherever you want to measure impact of water, etc. But yeah, I just thought I'd just share a different sort of application of it.
Fantastic. Yes, absolutely, Colin. Thank you so much. Are there any more ideas you'd like to share? Before we close at the top of the hour, what I'd like to do is just go to the assignments that are still due and all of that kind of thing. But if there are any more ideas regarding relating to robotics, please, let's discuss those.
There aren't any in the chat so far.
Okay, great. So let me just share my screen again, Brittany, and please let me know if what you're seeing is actually this email.
Yes, it is.
Okay. So in terms of this email that was sent a few days ago, I start off by saying we're very aware that many of you are busy with term end exams, and we'd like to make sure that you have time to submit your assignments. These are the assignments that will be due by the 30th of September. Experiment 1, so that is the one that we already did last week, and we covered this morning when we started at 11. Is there a relationship between natural light intensity and temperature? Experiment number 2 and experiment number 3 are the ones that are coming from today. Does the fridge light go off when I close the door? And does it still get colder after daybreak? And so for those two, you're definitely going to need to have your dashboard up and running, because you'll need to take a screenshot of your dashboard to actually prove your conclusion. And then your robotics idea, which is a maximum 60-second video. Please make sure that you start these experiments well before your deadline, as some of them may take days to conduct, especially experiment 3. Grades and awards. Each of your experiment submissions will be, sorry, there's a typo, they will be graded and added to the scores from your quizzes. There is a UNDP award for the top student and 5 X in a box prizes for the top 5 students. Robotics ideas, 3 UNDP awards for the top submissions relating to the 3 Sustainable Development Goals, number 7, 13, and 15. And the award ceremony will take place on the 9th of October. So that is going to be a virtual Zoom event. It's on the Saturday. It's on the Saturday morning. Some of those top award winners will be invited to actually attend the ceremony, which will take place at Saibono in Gauteng, in Johannesburg. And so if you are one of those 3 robotics ideas winners, you will be flown to Johannesburg and transported, etc. All of those costs are covered under the program, yourself and a guardian. So I really, really do encourage you to submit those by the 30th of December. And the reason why we had that cutoff date as the 30th is that, if the award ceremony is on the 9th, then we need the time to grade everything, to select the winners, make the bookings, do all of that kind of thing. So please, there is no extension beyond the 30th of September. And just for convenience sake, let's say the deadline's going to be midnight on the 30th of September. As I said, the award ceremony will take place on the 9th of October. You will receive emails and communication relating to each of these experiments. And this Saturday, which is today, we will cover experiments 2 and 3. Okay, so what I'm going to do is after this session, I am going to send you 2 emails, one relating to experiment 2 and one relating to experiment 3. What you're going to find is that in each of those emails, what I'm going to do is that I'm going to share the links to videos that I've made that have covered actually how you develop your dashboard. And in the breakaway room earlier, I covered a lot of that. But what I do is that I definitely cover it in those videos, so that you'll be able to build those dashboards. What I am happy to do is that I am happy to have some catch up on Wednesday after Carl's session, which will be between 5 and 6. So probably between 6 and 6:30 on Wednesday. I'm very happy to do another session regarding dashboards. So does anybody have any more questions for me in that regard? Brittany?
No questions.
Okay. Okay, good. So let me actually just go back to the PowerPoint. When we discuss these experiments. Okay, so what I want to do is regarding these 2 experiments, does the light go off when I close the fridge door? And also, does it still get colder after daybreak? What I really would like you to do is actually go through this set here of questions that we ask ourselves. What is it that we want to understand, or what is the question? What data will you need to collect to answer your question? How will you collect your data? The location, if you're going to have a route, a sequence, how are you going to do that? How can you test your results to make sure that they're valid? And then also, how can you present your results? Brittany, I see that your hand is up.
Yes, when you're done going through the slide, I just want to give some context on possibly how they should submit, and a sort of format that would be easy for them to follow.
Actually, why don't you do that now so we can begin with the end in mind?
Okay. So basically, most of you would have started natural science, grade 8 or 9 at least, or grade 7 even. They teach you about doing a scientific report. So you are doing an experiment, you'd want to start with some sort of hypothesis. In that hypothesis, you'd want to ask the questions, as Judy mentioned in point 1. So that's the sort of write-up you'd want to have. And then you'd want to start with hypothesis, and then your method would be explaining how you're going to get the data sets that you want to find to answer the question in your hypothesis. And then you'd want to have a section for your data collection. So that would be any graphs, any data tables relating to your results. You'd want to have a sort of results table, and then you'd want to have a conclusion where you look at your data, what you've collected, and if it correlates to your hypothesis. That's the sort of layout you'd want to go for the experiment, because there has been a few submissions where they just sent me like the graphs, which isn't necessarily the entirety of the experiment. We can't grade you a full grade or anything significant for just graphs, because it's not necessarily explaining anything. And especially in terms of your graphs, you want to also have names on your axes and a name for each graph so that you can explain what the data is. You need to write your experiment like submission out as if we were a complete layman and we didn't know what the experiment was, because you want to write it in such a way that somebody who doesn't know what you were looking at, or they didn't necessarily give you the experiment to do, that they would be able to understand what the experiment aims to be and be able to understand all of that data that you've collected and your conclusion versus your hypothesis from your like experiment or lab report.
Brittany, yes, you're absolutely right. It needs to be very, very clear in your submission that you're answering the question. So in the first experiment, the question was, is there a relationship between natural light and temperature? And we gave you some tips. And one of the tips was that you collect data in 6 different places. And so what is the answer to the question? if we're asking the question, is there a relationship between natural light and temperature? The answer is either going to be yes, there's a relationship, or no, there isn't a relationship. If the answer is yes, then you need to explain, how does this data give me an answer of yes? If there's a relationship, then we'll have a straight line of some kind. You know, as your lux increases, your temperature also increases. So there's a direct correlation there. If there's a situation where your lux is increasing, but your temperature is decreasing, then you've got an inverse relationship. If the data is all over the place and you cannot draw a conclusion and there's no correlation, then the answer is no. No, there is not a relationship between natural light and temperature. Okay, so that is, it's always about what is the question that I'm being asked? So what is my answer and why do I give that answer? You need to back up that answer with the data, with the evidence. Okay, you know, I always laugh because a friend of mine, you know, she always gets so upset when people say, just because, you know, it's kind of like, no, where's your evidence? Where's your data? You know, my friend Natasha is very like that. It's like, where's your data? Because she's a very strong scientist. So you can't just say, oh, because I say so. That doesn't fly in the scientific world. So what I'd like to do now, Brittany, is based on that, if we have a look at our first question for today, which is, does the fridge light go off when I close the door? What possible answers do I have to that?
You either have yes.
Tafara?
No, sorry. I got carried away, you can say.
Go for it.
It's either yes or no.
Okay, but stay there, okay, because I'm going to ask you another question. Okay, so yes, your answer, the answer is either yes or no. My next question is, but how do you know? So in other words, if you asked somebody else to close the fridge and you were not in the same room, how would you know that the door was closed, the fridge door was closed?
In terms of what? In terms of the results I've gotten, or just in general? So if I wanted to know if the fridge closed, I'll look at the results. The results will speak, basically. So
result of what results? You mean data?
Yes, the data.
Okay, what exact data are you going to be looking for?
So the experiment is if the fridge closes, I mean the light of the fridge closes when the fridge closes.
Yes. Okay, so you're going to be measuring light. That's the one thing.
Yes.
Light intensity. Lux. Okay, light intensity. That's the one thing. What other data are you going to be looking at to prove that the door is actually closed? What happens when you close the fridge door? What happens inside that fridge?
One simple way of looking at it, when I close the fridge door, it makes a sound. So to ensure that the fridge has been closed, it makes like a beep or something.
Okay, but there's something else. There's something else that should happen when you close the fridge door. The fridge is working, isn't it? We assume that the fridge is working. So what happens to the temperature when you close the door?
Doesn't it drop?
Yes, absolutely. So if your fridge is working properly, as soon as you close that door, it's going to start getting colder in the fridge. So if you put your kit into the fridge.
Okay, I see. Now I get it.
Okay. So you'll know if you're monitoring your data on a dashboard, okay, you should see the light go off because the light intensity should drop dramatically. And then you should
Yes.
see the temperature
The
starts.
temperature.
So then, therefore, you've proved that the door is closed. It's because you look at the temperature, not only the light.
So, so temperature and light
Temperature
are the
and
two
light.
variables that we'll be looking at.
Yeah.
Okay, makes sense.
Okay, so the thing is that, so the answer to the question, does the light go off when I close the fridge door? The answer hopefully is going to be yes. And how do you know that the door was closed? Is because your temperature was decreasing. So you're going to be looking for those two. Okay, so let's go. We've got 1 minute left. Tafara, you know what I want to do is, Reza, where are you? Reza, do you want to actually answer this next question, this next series of questions?
Hi, hello.
Hi, great. Okay, so the next question we have for our next assignment is, does it still get colder after daybreak? So what I'm going to do is I'm going to give you a little bit of background to this. And that is, when I was a kid, during school holidays, we would often go on camping holidays. And my father always used to say, please remember, you've got to bring something warm to wear in the early morning. And if it was summertime, I would be like, oh, my dad's crazy. And then I would always argue with him and say, but it's summertime, it's not going to be cold. And he would say, I promise you, when just as soon as the sun comes up, it's still going to be getting colder and you're going to need something. And he was right every single time. So I want to know, at daybreak, when the sun starts to shine, when the sun comes over the horizon, I want to know, does it still get colder for a while, or does it start getting warm straight away? So, Reza, what is the answer to my question? What two possible answers do you have to the question, does it still get colder after daybreak?
So, to my knowledge, daybreak is when the sun just starts to come up, I think.
Yeah.
Like dawn time?
Yes, dawn, yes. Does it still get colder after that? What are your two potential answers?
So, firstly, I think just as the starts to rise, it will get warmer, but not necessarily warmer right away. It will still feel colder.
Okay, so the answer to the question is either going to be yes or no.
Yes.
Either yes, it keeps getting colder, or no, it doesn't keep getting colder. It's getting warmer straight away. Okay. So the thing is that what you want to do is you want to track your data from before the sunrise till probably about 2-3 hours after sunrise. Okay. And then, so what two sets of data are you going to be looking for? What two sets of data are you going to be monitoring to answer this question?
I think the temperature and maybe the either UVI or lux levels.
Absolutely. So yes, the question relates to temperature. So you're definitely going to be looking at temperature. And then yes, the next one is there's the indication of daybreak or dawn is going to be light. And you are absolutely right. If you do have a sensor that's going to give you UV index, you definitely want to see if you get any ultraviolet lights, because that will only be coming from the sun. It's not an artificial light. Because I know that certainly when I do that experiment, what we have is we have a neighbor and he works shift work. So where I collect my data, if he wakes up at 4 in the morning or 3 in the morning and he turns his light on, my sensor will think that the sun's come up. So I always look for my UV index. When that starts to rise, then I know that the sun itself is actually up. So yes, that's a really, really, really good, that's a really good analysis. So yes, thanks for that. Yeah, so what I think I need to do is I think I need to start rounding up for today. Are there any other questions? Brittany, what do we have here? Is there anything else?
Not really.
Okay, so that's absolutely wonderful. So everybody, please look out for my emails regarding those assignments. And then also, please look out for the invitation for the session on Wednesday. So what it's going to be is it's going to be Carl Schumacher's session on how to take a great photograph of yourself using your smartphone. So that session will start at 5 on Wednesday. And then what we'll be able to do is before that, perhaps have a look at a little bit of troubleshooting before 5 p.m. And then maybe after his session, we can do a little bit more on dashboards. Great. Tunde, do you have a question? Okay. Brittany, I think that's it for today. So thank you, everyone. This has been absolutely wonderful. I want to say thank you very much, Brittany, and thank you, Colin, and thank you, Milena, for and everybody for your contributions. Great. And so I'll see you on Wednesday and of course, next week, Saturday. Next week's workshop on Saturday is going to be our final workshop. So there we're only going to really talk about robots and robotics projects. Great.
Thank you so much.
Thank you.
Thanks,
Thanks everyone.